Hi everybody, learn about the segments and their measures. We are going to learn about how to measure the segment distance and also some geometry postulates. So let's talk about ruler postulate. Okay, what is that postulate means? For example, if I have a line and I have two on the line, I have 2 points, point A and point B. Now if the real number, these are points A, B, these are letters. If the real numbers corresponds to a point, we call them coordinates. For example, this is x1 and that's x2. These x1 and x2 are real numbers. Okay, and A and B, these are the points, like names of points, but these are real numbers. So when the real numbers corresponds to the points, we can find the distance of the segment. And how do we find that? You know, distance is always going to be positive, so it has to be in absolutes. For example, if I'm looking for the distance of this segment, this line AB, then it's going to be AB equal absolute x2 minus x1. Now if you say, okay, why didn't you do x1 minus x2? It's not going to change anything, but the way you do it, always it comes, I mean, just the positive numbers or sometimes negative, but either way you can do it. It's not going to change anything. So that's our distance for the finding a distance of the segment. Okay, let's try this example. I have this example right there, and the question is asking find MP. This is my M and that's my P. So how do we find it? Now the distance between the points, right? And there has to be positive. So let's try and finding it. We're gonna say the coordinate of M, let's make this pink, is negative 11. Okay, now I would say the coordinate of P is 5, positive 5. Now if I'm gonna set it up. So how would I set it up? I would say MP is equal absolute lines, and I'm going to do either way, either x2 minus x1 or x1 minus x2. Let's do both. So let's do this one first. So x2, for example, this is my x1 and that's my x2. Okay, x2 is 5, so I'm going to put 5 with the blue minus, and I have parentheses negative 11. Okay, I got negative 11. Now what do I do here? If you pay attention, negative turn positive. 5 plus 11 is going to give me, it's going to turn 5 plus 11, and it's going to give me 16. Okay, the answer is absolute 16. When you take it out from the absolute, it's going to go 16 anyway. So that's my answer. If I do the other way around, for example, I have absolute lines and I'm gonna do opposite of that. So I'm gonna say negative 11 goes here, and subtract, I'm gonna go 5. You know it's gonna give me negative 16. When you take it out from absolute, it's gonna turn positive 16 anyway. So the distances between MP is 16 units. Okay, let's talk about congruent segments. So let me move this just a little bit down there, and then we will answer blue one. Okay, so let's try this. We are talking about congruent segments. Okay, so congruent segments have the same length and called congruent segments. And the symbol we use, okay, congruent has same length. So congruent segment means same length. The notation we use is this, a symbol. That's a congruent symbol. So let's talk about this. AB and DC, I would say AB segment is congruent to DC segment. And if I write this like AB is equal DC, then it means their length is equal. AB length is equal DC. The same thing goes for AD. If I have AD, because do you see these are the lines, which means these two are congruent and that two are congruent. So AD segment is congruent to BC segment. And I can say AD length is equal BC length. Do you see the difference? Okay. How to measure congruent segments? So what I'm going to do, I'm going to use the same shape and we're going to figure it out. This is the figure that I'm using for congruent segments, an equal length. So I would say BC is equal to, for example, let's try that. BC, and this is one of my example here. For example, BC is equal to feet. Find AD. Find AD. Okay. So the question is going to go something like this. We do know this BC is equal AD because I can see from these lines, the small two lines, it means they are congruent. So I can say BC length is equal AD length. Their length is the same. So if BC is equal to feet, then AD is equal to feet because they are congruent. Okay, now let's try something here using this diagram. They said given the figure is segment BG, these two, BG is congruent to segment AC. Okay, BG is congruent to AC. So the solution is going to be, let's figure it out BG first. Here is the BG. This is my BG. Okay, so absolute, I'm going to start with the G. Okay, this is the way I do x2 minus x1. Okay, BG is 3. Subtract -6, absolute close. That's BG. So let's solve this further. And I have 6 plus 3, 6, 7, 8, 9. So it's absolute 9. We're going to take it out and it's 9. Let's try AC. And again, absolute. C is, what is this? -1 minus A is -10. We can solve this. First change that to positive, like -1 plus 10. You know, I multiply these, negative times negative is positive. And when you do this, it's going to give you +9. And I can take it out and it's +9. Okay, that's why we're going to say AC is congruent to, segment AC is congruent to segment BG. Or you can say the distance are the same. Okay. Now let's do something. I'm gonna use that, but not yet. Okay. So let's do one more thing. Another postulate. That postulate is called segment addition postulate. Segment addition postulate. How does this work? I'm going to draw a shape first and then we can go from there, okay? I have, like, for example, this segment, and I have like 1 point here, 1 point here, and I can say one is right there. So this is A, that's a B, that's a C point. Now, according to this, if you guys pay attention, A, B is right there. Like, I'm gonna make that, that's A, that's a B, right? One more there. And then this is a C, okay? Now, if you pay attention, AB plus BC will give me AC. Do you see that? Okay, let's try that line from here to here. Okay, it's not straight, but I mean, that's okay, I think. Okay, I'll try to make it straight. Okay. Okay, that's the distance, okay? Now I can tell AB plus, this is AB, and that's BC, okay? And both of them, when you add them, you will get AC. And I can make a different color, shape this, and here we go. You see that? So this is AC. So the postulate, since you can tell segment addition postulate, so you can tell AC is equal AB plus BC. It will give you AC, okay. Now let's try move this diagram over here and let's figure it out what this one is talking about. I'm gonna draw a line so we don't mess up that. Here we go. Now let's see. If I have this is do you see this line M? It's intersecting, or it's cutting this segment AC in two equal parts. Why would I say equal? You see these lines, the small pink lines? So they are, the small pink lines are with just one line, which means the length of this is equal the length of the other one, the AB. The length BC is the same as length AB. So that's why I said they have the same length, and it's cutting it in middle, in between. So the midpoint, this B is called a midpoint. So is a midpoint of a segment is a point that divides the segment or bisect a segment into two congruent segments. Okay, let's try and write down some of the statements. For example, true statements. B is the midpoint of segment AC, and you can tell that B is the midpoint of segment AC. Next, line M, I mean these are all true statements. Line M bisects AC, there, segment AC. Now I can also say line BD, a line BD bisects segment AC. Okay, now I also have, like, look at the diagram, and I'm writing down everything that I see there. I can also say AB segment is congruent to BC segment. True. Again, the length of AB is equal the length of BC. Perfect, right? So, for example, when the line or array or segment or plane that intersect a segment at its midpoint, we call this segment bisector. So this line that I'm saying, like line M, is also called segment bisector. Okay, so it's called segment bisector. That's important. Okay, what else we need to know? Let's do some examples for the segment addition postulate, that one. Okay, let's do some examples there. I'm gonna draw the shape and I have a segment right there. It's supposed to be straight line. Okay, and then I'm gonna make another one. Same thing. Okay, there you go. Let's do the first example. I'm gonna make, let's use different color. I want different color. Okay, so here is the points. That's point M. This is point P, and the one up here, I'm gonna make point N. Now let's try this. This portion is 5x plus 1, and that one is 11x minus 2. Okay guys, so this question is asking if MP is equal 47, find MN and NP. Okay, so and MN is 5x plus 1 and NP is 11x minus 2. Now we're going to use our segment addition postulate. If it says if MN, according to postulate, MN plus NP will give me MP. You see that? MN, this portion, plus NP will give me MP. We already know MP is 47, so we have to replace that. MN was a 5x plus 1. This plus stays, and NP is 11x minus 2. Right there. So it's an equation. All we have to do is combine like terms, which is 5x and 11x are like terms. So that will give me 16x. 1 subtract 2 will give me -1 and equal 47. Add 1 both sides because this one has to jump over and combine with 47 will give me 48. You divide 16 both sides. It will give me x equal 48 divided by 16 will give me 3. So the question is asking find MN. They never said what is x value. So I have to plug in that x for 5x plus 1. Okay, so 5 times 3 plus 1 will give me 15 plus 1, 16. So MN is 16. If I 11x minus 2, which is NP, plug in 3 for x, and it will give me 33, subtract 2, which will give me 3, 131. So this is 31. And when I get that, 16 plus 31 will give me 47. Okay, so that's what this postulate means. Okay, now let's find a midpoint. I'm going to use a different color. For example, I have a point here A, I have a point here C, I have a point here B. And I said AC and BC both have the same length. And this is 8x minus 6, and this one is 7x plus 3. I don't know actually what the length is for AC and CB, but I know they are the same, they are equal. Okay, point C is the midpoint of segment AB. Find, the question is asking, find AC, CB, and AB. Find all of them. Okay, so let's try. We already know AC is equal BC because they are exactly have the same length. So we know AC is equal BC, or you can say CB. There we go, CB in order. So AC is 8x minus 6. CB is 7x plus 3. Combine like terms, we subtract 7x, because 7x and 8x are like terms. This will give me x minus 6 equal 3. Then we combine 6 and 3. Since 6 is jumping over the equal, we use opposite operation. 6, 7, 8, 9. So x is 9. This is not my answer. The question is asking AC. Finds AC. So I have to plug in this x equal 9 in here. That's my AC. So 8 times 9 minus 6. 72 subtract 6 will give me what? 72 subtract 6 will give me 66. Okay, so AC is equal 66. Let's find out CB. This is AC equal. Okay, I just want to write that. Then we have a CB equals 7x plus 3. Plug in that 9 for x. 63 plus 3 will give me 66 again. You see, that's why they said they are congruent. They have the same length. The segments are congruent too. Okay. Now I figured it out, AC, CB. Now what is AB? You add them together. 66 plus 66 will give me 66 plus 66 will give me 132. So that would be my answer for this one. Now, if you guys have any questions, comment below, like my video if it helped, and subscribe my channel. Have a good day, guys.